Okay, let's go ahead and get started. We're doing radical expressions today. And I want to start out by looking at another way we can think about fractions and integers. Okay, if we had something like 9 to the 1/2, this is actually the same as saying like 3 squared, okay, to the 1/2. Okay, so if we square 3, we're going to get to 9. Square root of 9, we get to 3. Okay, so what would cancel this 2 here? Okay, so if 3 squared is the same as 9, oh, a little bit out of focus there. So if 3 squared is the same as 9, then I would apply this 1/2 power to both of these at the same time. Okay, then they are equivalent. And we're going to learn in a minute that we can put these together in such a way as this. What about 3 to the 2 times 1/2? What is 2 times 1/2? That would be 1. So that would be like 3 to the first power, or just 3. So all of these are equivalent. 9 to the 1/2, 3 squared raised to the 1/2. If we multiply 2 and 1/2, we get 1. 3 to the 1/2 is 1. So that's just 3. So there's different ways we can represent these. What we have here is actually exponential form. And the other way that we might see these would be as in a radical form. So what if we had something like this, square root of 9? We would be able to recognize that as 3, most of us, pretty readily, okay? And that's what we're going to practice and learn about today. So let's look at another example. So if we have 2 to the power of 2/3, this would be the same as writing 2 squared and raising that to the 1/3. Now we know what 2 squared is. We're comfortable with seeing that anyway. But what about this to the power of a fraction? So don't get scared off too quickly. All that we're going to do, and we're going to learn in a little bit, that we have power in the numerator and the root in the denominator. Okay, so it used to be a power of 2. Okay, power. The root is still in the denominator. We're going to fix that in this next step. It's not really fixing it, just putting it in a different format. So if you put something to the 1/3 power, that's like saying we want the third root, or the cubed root. Okay, and you're probably seeing a pattern emerge. What if we did something else, like 7 to the 5/9? So again, the power that we're used to seeing is actually going to be 7 to the 5th. So that's the power. And the root of the radical is going to be the 9. Of course, we can separate these into something like this and evaluate. We're not going to evaluate it, but put it as 7 to the 5th power and put the 1/9 on the outside. So we're kind of breaking this apart piece by piece. So we're applying the 5 directly to the 7 as a power, and then we get rid of the 1/9 power by putting it in its house. What kind of house is this? It's a ninth root house. Okay. All right, how are we doing? Any questions on that so far? I want to make sure that we have a good understanding of that. Remember, you can post your comments on the floridamathlive.com, and that's actually where you see what we're actually writing down here. If you're watching from the behind the scenes camera over here, that is. Okay. We're going to see more examples. Let's try a few more examples. That's the best way to do it. What if we had x plus 3 on the inside of a square root? Now, how this would be represented would be x plus 3 inside of parentheses, okay, because we notice this roof of this house that it's under, it's not just over the x. This roof extends all the way over past the 3. So this root is being applied to that whole expression. And we know it's going to be a fraction, 1 over something. 1 over what? Well, before we started adding all kinds of crazy numbers over here, we were probably comfortable with calling this a square root. So I'm going to kind of write my 2 dotted like this because it's an understood 2 if we leave no number. Okay, if there's no number placed there, we understand and all agree that it's a 2 for a square root. Just like, we don't have to do it, but we could put parentheses around this. And how many sets of parentheses of x plus 3 are there? Just the 1. And that 1 would correspond to the power here. Okay, so some of the simpler examples are actually, I think, the more difficult to understand. Okay, so that's going to be to the 1/2 power. That's how we would write this example. Okay, so we have the radical form up here and we have the exponential form down here. How about this one? Okay, so this is a little bit more complicated. You think, wait, what are you doing with this 22? It's a little bit of a distraction, but for the conversion that we're talking about, we're only going to be able to convert this part. So this stuff over here, that's just going to drop down. I can actually take care of that already. That's going to stay at 22. Okay, now we recognize that this whole expression of x minus 9 is inside of the radical. So I'm going to put inside of parentheses, I'm replacing the house with parentheses. X minus 9. Okay, if the parentheses were inside the house, we could do that. It doesn't change it mathematically, but it would be to the power applied to this x minus 9 is 1. So it's going to be 1 over the root 5. So we simply have x minus 9 to the 1/5 power instead of inside of a radical. Whoa, getting windy in here. And then the plus 22. Notice the 22, it didn't really do anything. It was just there to be a little bit of a distraction. Now let's go the other way. What if we had 16 to the 1/2 power? So before we were given the radical and asked to put it into an exponential expression. Now we're given an exponential expression and asked to turn it into a radical, or if possible, can we turn it into an integer? Okay, so 16 to the first power. You don't have to write these first power things every time, but I just want to be super explicit about where each thing's going. So that's going to be 16 to the first power. And we're going to put all of that inside of a radical. And what type of radical are we having? A 2. So I'm going to put like a dotted 2 again because it's optional. What I mean by optional is if we left it blank, we agree as we do these math problems, everyone agrees that it's, in fact, let me just go ahead and fill it in. So square root of 16 to the first power, that's the same as writing it like this. Okay, notice I got rid of the 2 and the 1 only in this specific case was the square root. And of course, when someone asks how old you are and you say you're 16, you're not going to say 16 to the first power. You just say 16. Now, 16 is one of those numbers that we should start to be familiar with. What is the square root of 16? That's 4. Ready for another? How about 5 to the 2/3 power? So we'll first give the 5 the power of 2, put it inside a radical, and what type of radical are we doing? Cubed root. Now let's see if we can actually evaluate to get a number. Can we? So 5 squared is 25. That would still be inside of a cubed root. Now we have to be careful. You say, oh, isn't the square root of 25 5? Yeah, the square root of 25 is 5, but this is the cubed root. Is there any cubed root? So 3 times 3 times 3 would give us 27. 2 times 2 times 2 would give us 8. So this is not a perfect cubed root. Let's see if we could find one that is. How about now I'll take this moment to say we can write these in 2 different ways. Okay, we can put the parentheses and apply the power after the root like this, or we could put the parentheses with the power inside the root, and it's the exact same result. So here's what I'm talking about. Okay. Now logically, which one would make sense? These are both mathematically correct. If we work our way from the inside out, as we usually do, I can do one of these in my head and the other I cannot. So the square of 125 is a big number. Not sure what it is. It'll be a big number. So if we were to square it, find that big number, and then try to think of what the cubed root of that big number would be, that would be a long journey. That would be difficult. We'd need a calculator anyway. I wouldn't be able to do it in my head. But this one, with practice, we're going to realize that the cubed root of 125 is 5. 5 times 5 makes 25, and then 25 times 5 makes 125. So the cubed root of 125 makes 5. Don't forget the parentheses. And now we evaluate the squared, the power. So 5 squared is 25. All right. I'll leave that up. Check if we have any quick questions on that topic. Looks like you guys understand. Thumbs up. Thank you very much. Thank you, thank you. Glad you get it. That's the important thing. Glad you understand. Okay. Okay, all right. So let's carry on. What else can we learn about this topic? We're going to try a few examples, and then I think that's the best way to learn these, is just go through several examples. These are all things that can be prevalent on the end of course exam for algebra. All right. What if we have something like the square root of x? And we're asked to write an equivalent expression to find the exponential form of this. Now, it'd be fun to use some colors. How about that? So we don't have to put these numbers on, but sometimes it helps us to understand, especially in the beginning, what's happening. So square root of x is the same as if I wrote, that would be x to the first power. And the radical, that would be if there's no number specified, we all agree and understand that it would be a 2. Okay, so now what's inside of the radical? If there's more than one term, remember terms are separated by plus or minus signs, there's only one term in here. So I would write x. We wouldn't need parentheses to specify that all of this used to be inside of a radical, so I can just leave it as x. And then there's going to be a fraction, pretty sure, right? What was the power? The power was 1, and the root 2. So how do you remember which of these is which? Well, if we remember square root, then we know that cube root or fourth root or fifth root, all roots are associated with this spot over here. All of us have been pretty accustomed to seeing these root signs. And powers, we've been used to seeing exponents and with raising something to a power. How I like to think about it is you look up, you think powerful, oh, that's amazing, look how powerful that jet is up there. And then you think about roots. Roots exist under the ground, so under the division sign resting inside of the denominator. Let's try another example. Let's do 2 plus k. And let's do it to the 7th power. And we're going to put it inside of a radical. It is a 9. Getting my color scheme mixed up a little bit here. Sorry about that. So the root is 9. The power was green. Make this blue again. Okay, so let's follow that pattern again. So I'm going to rewrite 2 plus the letter k. Now this was almost a little bit easier because it told us that these parentheses, it reminded us that those were supposed to exist in parentheses. Power of 7. And what is the root? What goes underneath? That would be the 9. Okay. Now another way that may be less obvious, or maybe the same obvious, I'm not sure. We could also write the same question could have been asked this way. Okay, these are the same. You can see them presented either way, but they end up giving us the same result over here. Okay, so this would be like maybe if we were to do it in order, so maybe we'll do the radical first, the root first. So we know that all of that is inside of the radical. So we know we need some parentheses. And then when we make our fraction, the 9, because it's a root, is going to go underground. Power goes above, just like that. All right. What if we were to put some in the other direction? What if we were given the exponential form and we were asked to put them into a radical? What about like k plus 5, and it's in a radical like so. Now we want to go into an exponential form now. So what would that end up looking like? So we have to be careful. So what is the radical applying to in this case? So the radical is only applying to the k, not the 5. So I'm just going to write the 5, the plus 5 over here to the side, because that's not going to take any type of adaptation from the k. Nothing is going to change about the 5. We will have a k. There's only one term inside the radical, so we don't really need parentheses. We know there's going to be a fraction for sure. And we have to think, what is the power of the k here? If there's nothing there, then we understand it to be 1. And what about the radical? If it does not specify the radical, then by default it's 2, correct? Remember that? So by default it's a square root if they don't have a number there, which means the denominator over here would be 2. Okay, so I think that about does. Let me check one more time, see if we have some specific questions on the topic. Otherwise, make sure you get those questions submitted ahead of time. You can send them in via Messenger. You can also submit them in the comments, and there's a comment feed on FloridaMathLive.com. That would be a good place to put the comments, okay? All right, I'll stay on for one more second if there's any questions that come up. But otherwise, have a great evening, guys. Good job today.